Okay, lads, so first things first, I just want to show you a little trick that we may not be aware of. So, when I prove that two triangles are similar, so this small triangle inside the large triangle is similar, okay? So let's say I say that's, I need probably a stronger example of this. Imagine I said that this one is size 10 from here to here, size 5 from here to here. This one is size 14 from here to here. That automatically means that this one is size 7 because 10 divided by 5 is 2. So the top length is twice the length of the bottom length. Now, if I was to label these A, B, C, X and Y, you could also say that AX divided by BX, 10 over 5, is in the same ratio as AY over CY. Okay, so using this logic, what we can do now is we can attempt question 3 quite fast. So what we have here is we can look at the triangle PABCR. Now the reason why I'm targeting that is I can see that I need AB. Okay, so it's a triangle that has AB in it. So let's try this out. We're going to do P to A because P to A is also in the answer. So P to A over A to B, similar to the 10 divided by the 5, and that can be the 14 and the 7 from earlier if you want, something like that, is equal to PC over CR. Okay. Nextly, we're going to look at this triangle here, which is going to be, we're going to look at this triangle here, which actually has the same trick as the last one. Okay. We can say that it's PB over BQ. See the way we can see PB and BQ there? So I chose to do it this way. Equals PC over CR. But the deal is that they're both equal to PC over CR. Okay, so that's PC, CR. This one's also PC and CR. So therefore the two yellow parts must equal each other as well. The reason why PA over AB equals PC over CR is triangle PAC is similar to triangle PBR. And the reason why I'm going to use this formula is the triangle PBC is similar to the triangle PQR. Remember we did that earlier where we said that PBC have a common green angle, the yellow angles are corresponding, and the two of them are purple angles. So essentially that one's the same as that one, this one's common, and this one is the same as this one. That's why they're both similar triangles. Okay. So therefore, we can now join the two yellow parts together to get PA over AB is equal to PB over Q. And you're done. Okay. Next we're going to do is question 4 from earlier. Okay. Now, once again, I'm just going to number these, okay? Number these might be the best way for me to do this, okay? So, angle 1 and angle 2. So, I have angle 1 plus angle 2 equals 130 degrees. Now, where is angle 1? Your angle 1, BAC, your angle 2. Awesome. PQR, which we'll now call angle 3, is 50 degrees. No bother. Equals ABC, which is also 50 degrees. Okay. Now we can say this one's angle 4 and this one's angle 5. Okay, so evaluate PQR, QPR. QPR is, so this question becomes evaluate angle 4 plus QRP plus angle 1. That's what I'm trying to achieve right now. Now, what I can prove right here, so evaluate QPR, Q to P to R, QRP. Oh, that's handy, because angle 1 plus angle 4 plus 50 degrees equals 180. Reason being 3 angles in a triangle. Okay, the 3 of them added together give you 180. Therefore, angle 1 plus angle 4 equals 130 degrees. Done. Prove that QPR equals BAC. So I'm looking to prove, this is part 2, I'm looking to prove QPR. I'm looking to prove that angle 4 equals BAC, angle 2. No bother. Because we know that angle 1 plus angle 2 equals 130 degrees. That was given. Now we know that angle 1 plus angle 4 equals 130 degrees. Therefore, angle 2 must equal angle 4. Two of them have to be the same as each other. Okay, so that's proven. Done. So now we know that angle 2 equals angle 4. We now know that both triangles are similar. Okay, so we're going to prove they're similar. So we can call this angle 3 from earlier. So to prove that the triangle PQR and the triangle ABC are similar. So what I'm going to prove here is that, okay, angle 3 1, 2, 3, 4, 5. Call this angle 6. Angle 3 equals angle 6, both 50 degrees. Angle 2 equals angle 4, proven in part 2. So that's proven in part 2. In part 2. Therefore, angle angle 1 equals angle 5 because it's the third angle. Third angle. And then what we can say then is that the triangles are similar because all triangles are the same. Now, given that the triangles are similar, therefore PQ, which is in between the yellow and the blue angle, so to speak. So I'm just going to match them up by color at this stage. That's blue, that's blue, that's black, that's black. So therefore PQ, yellow over blue, is the same as AB because they're similar. That's the only reason that happens. QR is is blue to black, and it's being divided by the other triangles, blue to black. Blue to black is B to C. Okay, and we're done. So that's question 3 and question 4. Now we're on to question 5. Okay, so In the triangle ABC, AX is parallel to BC. X is parallel to BC. Proof that YC equals YB. Okay, no bother. So we're going to call this angle 1. You can be angle 2. What else can happen here? You can be angle 1. You can be angle 2. I think we're seeing, yeah, AX1. So we're going to have to prove that YC equals YB. Okay, so let's label some angles here. The only thing we really have to work with is that AXY and AXY, which is this one here. I'm just going to drag it all down with me, and then I'm going to drag this one back up on its own. There we go. Angle 1, angle 2, and that's AXY, and then we're going to have ABC, which I'll just draw a bit normally on its own. ABC. We know that these two guys are going to be. We know they're going to be, what's that word, similar. Okay, so green angle's the same. I need to call that angle 3. This angle 4. This one angle 5. Here angle 5. And then this one can be angle 6 and angle 7. 6 and 7. Okay, so I'm going to prove that they're, first of all, they are, what's that word? They are similar to each other. Well, here. So I'm going to prove they're similar to each other. So that's I'll just put in the number. The angle sign's making things weird. That's 1. Angle 2. And that's angle 3. 3, 6, and 7 on the top one. And 3, 4, and 5 on the bottom one. And what I'd like to prove is that we want to prove that YC and YB are the same. We want to prove that angle 2 equals angle 5. If I can prove, so 1 is to prove angle 2 equals angle 5, that triangle YBC is isosceles. That's essentially what I'm trying to prove here. Okay, so let's start off. What we can say here is that angle 6 equals angle 4 because they're corresponding. Remember the F value here. So angle 6 equals angle 4. Don't know if that's going to. Sorry, angle 6 equals angle 2. I don't know if that's going to help or not. So angle 6 equals angle 2. Reason being is they're corresponding. Angle 7 equals angle 5. Angle 7 equals angle 5. Once again, corresponding. And then angle 3 equals angle 3. Same angle. And this proves that triangle ABC is similar. The 3 vertical lines mean similar to AXY. Now, the good thing is I know that angle 1 equals angle 2 because they're alternates. So angle 1 equals angle 2. Reason being is alternate angle. If you're wondering about an alternate angle, it's the Z in the process. So you see a Z here. Angle 1 and angle 2. Okay. Now, once again, I'm trying to prove angle 2 equals angle 5. Proof angle 2 equals angle 5 would be ideal. So, I think we might have something here. If I call this angle 8, okay? So, angle 8 plus angle 2 plus angle 5 equals 180 degrees because it's three angles in a triangle. Angle 7 plus angle 1 plus angle 8 also equals 180 because it's a straight angle. So you'd write in straight angle here, and all three angles add up to 180 here. Then we know that angle 7 equals angle 5. So we know that angle 7 equals angle 5, and angle 8. No, nothing new there. Nothing new there. Oops, never mind, lads. I actually missed a critical piece of information here. That angle AYX, angle 7 is actually equal to angle 7 is actually equal to XYB. Angle 7 is equal to angle 1. So that's good to know. Angle 7 equals angle 1. So this means angle 7 equals angle 1. So this means that angle 1 will equal angle 7, which equals angle 5. So now we know that angle 1 equals angle 5. Therefore, angle 1 equals angle 5. And we also know that angle 1 equals angle 2 because they're alternates, which is here. Therefore, to prove this question, angle 2 equals angle 5, which makes this isosceles. Didn't read all the information. My bad. And to prove that AX over AY is equal to BX over BY. Alright, that's handy enough. Now, I proved earlier that ABC and AXY are isosceles. So I proved that ABC and AXY are isosceles. Okay, so I already proved that. So, what I can then say is that AX AX over XB is the same as AY over YC. No doubt, I'll go through this first. I think we have it. It's AX over XB, and sorry, XB is the same as BX. So AX over BX, I keep it alphabetical, the first letter comes first, equals AY over YC. But we proved that YC equals YB, so that will in turn equal AY over YB, because YB equals YC. And then therefore AX over BX, excuse me, let's get rid of this nonsense from later. AX over BX equals AY over YB. And then I think we can cross multiply the BX up and the AY down, so we're going to get AX over AY equals BX over BY. Sorry, we shouldn't be using YB, we should be using BY. Alright, that's question 5 done. So I've done 3, 4, and 5. They are difficult questions. No doubt about it. 7. Okay, 3, 4, 5, and 7. Okay, so next one. ABDC is a rectangle. The lines BC and AC are produced to E and F respectively, where CEF, C to E to F is 90 degrees, no bother. prove that AB over EF same as BC over CE. Well, if I can prove that to have a similar triangle somewhere, yeah. I think I have it here. Angle 1, angle 2, angle 3, angle 4, angle 5, 6, 7, 8, 9. All right. I'm going to go for alternate first. I'm going to go for angle 1. I'm trying to prove that I think AB over EF. See, AB and BC, they belong to this bottom triangle here. Okay? And then I'm trying to prove that that yellow triangle is in fact the same, is similar to the blue triangle. I think that's what I'm after. So I'm after that one and that one. I think I have it. Okay. So we're going to go for triangle ABC. And I'm trying to prove it's similar to the triangle CEF. Now, remember vertically opposite angles, where if that's 50 degrees, that's 50 degrees, and if that's 130, that's 130. That's vertically opposite, okay? Because I'm going to use that in a second. So, here's what we're going to say. Angle 2 equals angle 4, reason being vertically opposite. Next thing we're going to say is angle 8 equals angle 10 because it's 90 degrees. Because the angle in the rectangle is 90 degrees, okay? Therefore, third angle is angle 9 has to equal angle 5. It's the third angle. Therefore, ABC, the three dots mean therefore triangle ABC, ABC is similar to triangle CFY. CEY. CEF. What does that even look like? Whoop, get out of it. Triangle CEF. Done. This means we can now use our little tricks. We can now prove that AB, so I'm just going to color code them for a second. 8 is the same as 10, and 5 is the same as 9. So AB, which is in between red and blue, therefore AB over EF equals BC over CE. That's because they're similar. DF intersects CE at a point G. DC is 8, CG is 4, and GE is 1. Find EF and hence find BC. Okay, I'm just going to get rid of my proof here. I'm hoping I don't need my angles anytime soon. I'm just going to maybe just colour them slightly. You're the same as you. You're the same as you. And you're the same as that one. Alright, let's see what I can do. So, CG is 4. D to C is 8, and E to F and G to E is 1. J. Ouch. G to E is 1. Okay. So that means we know C to E. C to E would be 5. Because C to G is 4 and G to E. So I think we have CE. We know that CE equals 5. Okay. We know that DC equals 8. And if DC equals 8, because it's a rectangle, AB will also equal 8. Okay. I'm missing something else here. So we have CE, we have AB, we don't know BC, and we don't know C to F. I'm missing something again. DC is 8, CG is 4, G to E is 1. Okay, I'll figure it out in a second. Now, I think I was looking for the answer in the wrong place, believe it or not. And it's hard to see, but if I take this big triangle and this small triangle, and what I can say is that the two of them are similar to each other. This wasn't enough information elsewhere, so this is a D, because D, D, C, and G. Now imagine G is, and then I'm going to make a GEF, the really tiny triangle. I'm going to make that a bit bigger, just for the sake of being able to see angles. So that's G, E, and F. Now, we know that this is 8 and 4, and we know that G to E is 1. Now, because of fairly opposite angles, we know that this angle here is the same as this one here. We know they're both right angled, which would make this one here the same as this one here. Therefore, the third angle has to be the same, which would be this one here is the same as this one here. So therefore, what we can say is that they're similar triangles, and GE corresponds with CG. GE corresponds with CG. So the bigger triangle is 4 times bigger. So this makes E to F divide 8 by 4 is 2. So E to F is 2. Now we need to find BC. Well, we have the formula here now. We pretty much have this filled out now, don't we? We know that AB is the same length as DC. So AB is 8. EF we found out to be 2. BC we don't know, but we know that CE is 5, because C to E is 5. Now all you have to do is find out what BC is. 8 is 4 times bigger than 2, so 4 equals BC over 5. This means that BC has to equal 20. Once again, a very, very tough question. These questions are quite tough. 3, 4, 5, 7. Now we're going to go on to 8. Just because we love ADX, ADX, and ABE. ADX and ABE. So, triangle ADX and triangle ABE. ABE, like so. Then drag the two downwards. Bring this back to where it was. Alright, let's give this a go. Now, what can we say first and foremost? We could do with labeling some triangles. Angle 1, angle 2, angle 3. 1, 2, 3. What we should call you is 4, 5, and 6. And then we can call this one 7 and 8. Now the good news about EXC is similar to EAB. So I'm going to prove EXC is similar to ABE to start off with. So we can say that angle 3 equals angle 5. Oh, sorry. Angle 3 equals angle 8. They're corresponding. Basically, DF. They're corresponding to each other. Next thing we can say is angle 6 angle 4 equals angle 4 common angle. Common angle. And then finally we can say that angle 6 equals angle 7. They're both corresponding, or it's the third angle. Therefore, EXC is similar to ABE. Happy days. Alright, next one. We know that already. That's great. Now, we're going to do ADX and ABE. So, ADX and ABE. So, what I'm thinking I can do here. Yeah, I actually have this already. So, angle 1 equals angle 7. So this is ADX. And this is triangle ADX. And this is triangle ABE. And I already have this because I have angle 1 equals angle 7. Opposite angles in a parallelogram. Okay. Next thing I'm going to do is, if you see an alternate angle, here it is. The Z and the 4, the 2 and the 4 are the same. The 2 and the 4. So basically, because of alternate angles, angle 2 equals angle 4. So angle 2 equals angle 4, reason alternate angles. And finally, angle 3 must equal angle 6. Oh, sorry, angle 3 equals angle 8. Ah, they're also alternate. Angle 3 is also alternate to angle 8, so yeah, whatever way you want. Third angle or alternate. Okay, therefore, triangle ADX is similar to triangle ABE. Those 3 lines vertical means similar. Okay, done. Happy days. Okay, happy to know this information. Now, EX equals 3/4 of DC. So essentially that's a ratio of 3 is to 1. show that BC is 3/4 of BE. So let's think of a letter that's not in use. Let D. Oh, sorry. Yeah, we have this all day long. We have this all day long. All right. Look at the triangle DX belongs to. Now, what I've proven earlier was I've already proven that ADX, triangle ADX, is similar to triangle ABE, and it in turn, they're both similar to triangle EXC. I proved all three of them. I proved that the two of these are equal, and I proved that the two of these are equal. Therefore, all three of them are not equal but similar. Okay. So here's what we're going to do. We're going to identify DX and DC. DX and DC. Now DC is the same length as AB. So let's color code these now. I'm looking to do next. Okay. You're green, you're green, you're green. You're blue, you're blue. And is there another blue? We'll find out. You're red, you're red, and you're red. Okay. You're DXA and you're EAB. B. You're red, you're green, you're blue, and you are. So these, if the colors are the same angle, basically. So I like to do them. Now, DX is in this one. DX is in between red and green and red. So, and then we want to prove that BC is 3/4 of BE. Well, that's no big deal because DX equals 3/4 of DC. But 3/4 of DC is actually also 3/4 of AB. Okay? So DX is 3/4 of AB. And you can see these are corresponding sides. So this means that the small triangle is 3/4 of the big triangle. A small triangle is 3/4, or sorry, you need to be more specific than that. Triangle ADX is 3/4 the size of triangle ABE. Happy days, you're explaining yourself, alright? Next thing we're going to do is show that BC, now what's BC the same as? BC is actually the same as AD. Okay, so we want to show that BC is equal to 3/4 AD, which in turn is the same thing as 3/4 of BE. And the reason for this is AD equals BE, opposite sides of a parallelogram. Yeah, you're right thinking this is hard, right? So what we're going to say now is AD, which is the blue line, corresponds to BE. So therefore, BC, therefore, sorry, BC equals AD. Sorry, my fault. BC equals AD, and I want to prove that AD is 3/4 of BE. Well, that's done because we've already proved that they are corresponding sides. Therefore, BC equals AD, which is in fact 3/4 of BE. Therefore, C is 3/4 of BE. And you're done. You've explained it to the best of your ability. 13. Oh, I really don't like myself. Right, last one. May we never do these again. They're horrible, horrible piece of math. Triangles SRP and QRT are equiangular. SRP, which is the green one, is the same as QRT, which is the yellow one. Yeah, that's reasonably obvious. They don't even need to give you that, because what they want to do is they say that this one here is the same as this one here, and then these two stand on the same arc. The red ones are standing on the same arc, lads. Do you remember that? Where P goes to S, ends at R. They're standing on the same arc. Look, P goes to S, ends at R, red angle. P goes to Q, ends at R. Q and S are points in the circle. This means that the two red dots are the same. They're standing on the same arc. They're standing on the arc PR all day long. And that means that this angle here, which I will do in green, is the same as this angle in green as well. Alright, let's get rid of that black dot. Didn't actually need it in the end. So, PR, which is in between green and blue, over TR, which is green and blue, equals RS, which is blue to red. Blue to red, this is R to Q. Done. Prove the following. PR multiplied by RQ equals RT squared plus PT multiplied by TQ. Okay, let's start off with what we had in the previous question. Let's cross multiply this. So cross multiply this and you get RQ multiplied by PR. PR multiplied by RQ. I bring this one up. Now I'm going to bring RS up to TR. Now, what is TR? Or what is RS? Oh, we have RT. So sorry, I'm not writing TR, I'm writing RT. My fault. TR and RT are the same thing. So I should have changed that to RT. So it's RT times RS equals PR times RQ. No bother. Next thing. Let's look at R to S. See the way R to S is not in our answer? Let's look at R to S. R to S is RT plus TS. So it's going to be RT times RS, but I'm going to change RS into, RS is going to get changed into RT plus TS, and that's equal to PR multiplied by RQ. And finally, you're going to put it into you're going to multiply, what's RT multiplied by RT? That's RT squared. Same thing as X multiplied by X plus Y. X by X is X squared, and then it's Y multiplied by X, and then it's also plus. So that's our RT squared. Now the next problem is RT plus T to S. No. Here's where we encounter an issue. Okay, so we have PR by RQ on the left. We changed RS into RT plus TS. That's no big deal. And then RT plus TS. And then we're going to get RT multiplied by TQ. Now, for some reason, we have to change RT by TQ has to be exchanged with PT. Now, we don't know, that's a misprint, because PT is not the same length as RT. So that's a misprint, lads. That's an RT all day long. Don't worry about that. Alright, we're done. That's us. A 46-minute class to catch us back up. Sorry about earlier.